Welcome back. We're going to do currency conversion. So this is all part of Unit 3. This is part 2 of Unit 3, focusing just on applications. So we learned a little bit or refreshed our memory regarding ratios in Unit 3, Part 1. Now we're going to apply those ratios in business contexts. Okay? So we'll do a detailed application using currency conversion as our context. However, the same ratios can be applied to any index numbers, whether that index number is the consumer price index, whether that index number is a stock market price index. Okay? All they are is applications of the basic tools that we learned in Unit 3, Part 1. They're just ratios. The context doesn't matter. We flow with that. One of the wonders of a university class is that we're educated, not trained. Educated means, okay, you show me the basic principles, I see an application in a context, and now I'm able to extend that to other contexts without a lot of intervention by others. You know, we're flexible that way at a university level. So one of the kind of neat things is currency, and currency has been represented by many different things. It's intended to be a store of value, a unit of transaction. And so we've evolved our sense of currency. There's, I think, I can't remember the island of Polynesian tribes. They had big, huge stones, and they exchanged rights to the big, huge stones, and that was their currency. Gold has evolved as a mode of exchange as well. And now we deal with mostly with what's called fiat currencies. That $10 Canadian note that you see right there with Sir John A. Macdonald on it. Why is it worth $10? Because we generally accept that the Bank of Canada will maintain this as somewhat of a store of value. And so we accept that it's got a certain value attached to it. But that's really a societal agreement on that. I had some Zim dollars, and I don't know what the heck I did with them, but Zimbabwe inflated their currency, and those are, you can get a couple of $1 trillion in Zim dollars, and they're really worth about, half a penny. Some other currencies. So we have the American dollar, our friends to the south, right? And I picked a $10 note because, I'm trying to be, culturally aware and express my artistic side. Of course, the $10 note has got Alexander Hamilton on it, and for those of you who follow theater and all that kind of stuff, Hamilton is like, woo, cause celeb, everyone's swooning over it. So there's Alexander Hamilton on the $10 note. Ironically enough, Alexander Hamilton was shot by the former Vice President Aaron Burr in a duel. So if you're thinking that American partisanship is at its worst, you don't have former vice presidents shooting treasury secretaries. So there's that. We have the £5 note from Great Britain, right? £5. It's a very nice note. It's got the polymer bill, same as Canada, because Mark Carney, who was the governor of the Bank of Canada, when we brought in our little plastic polymer notes, went over to the Bank of England, and guess what? One of the first things he did was turn all their currency into coins and polymer notes as well. So you have the Queen on the front, and you have good old Sir Winston Churchill glowering at you on the back. So £5 note. England, they make all their notes different sizes. Canada, we all have ours about the same size. We have, the Japanese yen, so great, the British pound, Japanese yen, which we'll be talking about when we start talking about rate exchanges. And you kind of see the yen there. Can't read most of that. You'll notice that there's a little bit of a gap in the middle. Sort of looks like it's like an empty space. If you held this note up to the light, it would be the same as the picture on the right. So it's kind of like a anti-counterfeit measure. In 2019, when we could all travel, this recording taking place in 2020, I went to Israel last year, and of course they've got the shekel, called the new shekel now. New shekel. Again, central bank is the Bank of Israel. Israel's got poets on the new shekels. They used to have political leaders on the old shekels, but the reason why they became old shekels is their currency got severely devalued with inflation, and they ended up having to replace it with the new shekel and be maybe a little bit more rigorous in how much currency they issued. So currency comes in all sorts of different shapes and sizes and units, and then the whole purpose here is now, okay, I want to buy something in Great Britain. The price may be quoted in British pounds. Well, I got Canadian dollars. So what can my Canadian dollars buy, or what is this value of this Canadian dollars in British pounds? Or how much Canadian dollars am I going to need to buy the appropriate number or appropriate amount of British pounds in order to buy the item that I want? Of course, being Canadians, we're very in touch with the value of the American currency because we travel to the U.S. or did travel to the U.S. quite a lot. And so we're aware of the value of the Canadian dollar in American terms, and so much so that it's one of the default or one of the regular things that are reported in the news cycle, whether it's the business news cycle or even just in the regular news cycle during the business segment. Okay. So, like it's been implied here, all an exchange rate represents, and we'll learn how to read these exchange rates in a sec, is how much of one currency will I need to buy another unit of, or 1 unit of another currency. That's it. Right? So very, very important. A couple of samples, and because we're pretty much in tune with the American dollar. So we'll start off with the currency relationship that we sort of understand because many of us have grown up with it for a long time, and even those who are new to Canada, it doesn't take long before you realize how important that Canada-U.S. exchange rate is. And one thing about U.S. dollars is they're widely accepted throughout the world. So even if you don't have local currencies, many times it's really easy to buy things in a foreign locale, i.e. foreign, not U.S., not Canada, and you still use those American dollars. Okay. So for some examples here, on August 3rd, 2019, the Canadian dollar was equivalent to a little over 75, almost 76 cents American. On June the 2nd, 2020, 1 Canadian dollar would purchase about 74 American cents. Okay, so we can represent this two ways. We could represent that as how much can $1 Canadian buy in American currency. Or we can flip this around and say, if I have $1 US, how much Canadian dollars can I buy? And that's what you sort of see at the bottom of the slide. Okay, we see that 1 Canadian dollar buys about 74 American cents. But we also see that 1 American dollar buys about $1.35, or on June 2nd, bought $1.35 in Canadian currency. Okay, so it's pretty easy to convert, and we start off with the intuitive understanding that we know that the American dollar at this point, and at most of the time, 2008, 2009. Accepted, the Canadian dollar trades at an amount, in magnitude at least, less than the American dollar. So we'll start off with that sort of idea so that when we read the cross table and we're dealing with currencies with which we're not terribly familiar, if we get confused or turned around, we can always refer back to that Canada-US exchange rate and see, am I reading this table correctly? So, for instance, we can see if we want to convert Canadian dollars to American dollars, we take the number of Canadian dollars we have, we multiply it by the 0.7393, and we get the amount of US dollars. So, if I have $10 Canadian and I want to see how much in American dollars can I buy with that $10 Canadian, I intuitively understand that if I do this correctly, I'm going to get a result less than $10. Okay. So, when I'm starting to think of, am I multiplying, am I dividing, am I doing this or that, I think, okay, I know the answer is going to be less than $10. So if I get an answer more than $10, I probably did something wrong. So I take the $10, I multiply it by the amount American, and I get the result. Behind the scenes there, that easy intuitive, is actually a ratio. Okay, I'm looking at $1 Canadian buys 0.7393 American, Therefore, how much will $10 buy in American currency? Okay. So the way I like to set this up, and then you have a variety of ways of dealing with ratios, and all I need is for you to pick the way that works for you. Okay. The methodology, there's many different methodologies. The answer is what's important, and there's many different ways to get to the same result. But I'm just going to keep my columns in Canadian dollars and in US dollars. That way I can kind of keep things sorted, and if I'm under stress or under the gun, or I'm at a meeting and someone's really put me on the spot and asking me to do quick exchange rates, or I'm on an exam and I'm being stuck doing the same thing, I don't get mixed up. So what do I know? I know that 1 Canadian dollar is equivalent to 0.7393 American dollars. So I know this amount. Now I'm asking myself, well, I got 10 Canadian dollars. Well, how much in American? I don't know, right? I'm going to figure that out. Right? This becomes a nice, neat little ratio. I got some nasty fractions, so I know that I'm going to cross multiply. Get rid of the nasty fractions. X times by 1 becomes X, and that equals to the 0.7393 times by the 10, right? And that's exactly what we see on the slides. So the slides show us a short form, and a lot of people are intuitively, yeah, I can figure this out, I can roll with this because I'm familiar with Canadian dollars and American dollars, but there was a ratio involved in the background. Same kind of idea if you're converting US dollars to Canadian dollars. Same exact idea. Now you can look at the cross table, you can look at the currency exchange rate, and you can do the calculation. I'm expecting that if I have $10 American, that's worth more than $10 Canadian. Right? So if my check on my answer is that. And so I look at my currency cross table, which we'll look in a sec, or some reference sheet, and I take that $10 and multiply it by the $1.3526. Okay. Same kind of idea. The other way you could have done it, you could just switch this 10 and this X around. And then you're dividing by the 0.7393 instead of multiplying, and dividing 1 divided by 0.7393 miraculously turns out to be 1.3526. Okay? Wonders of ratios. Once we have the organization on the ratios, everything really falls into place. So some technical, if we know the exchange rate from currency A to currency B, the ratio B and A, we can then find the exchange rate from B to A. Just taking the reciprocal, which is just exactly what I just said. Okay, that 1.3526 is miraculously 1 divided by 0.7393. Okay, so it's really, really easy. You can pick the denominator however you like, whatever makes sense. I pick it. I mean, there's the way that where you would put the X in the numerator, but whatever way works for you is fine. I'm going to be picking a way so that when I talk and when I read the question, I can just flow down from top to bottom, which means usually you're given the exchange rate first, so that becomes the numerator, and then you're given the amount you want to exchange second, and that becomes the denominator. Sometimes in the calculations, it's maybe easier just to reverse the two, but it doesn't change what we're doing here. Okay, so you wanted to convert $150, and like I said, it's the same as what we did before. Okay, so set up the ratio just like we did with the previous question. Cross multiply and solve. Okay, we'll leave this up to you. The answer is there. But try to take the question in words up here, solve it on your own, and then look at the answer to see, okay, did I follow along fine? Okay, so that's practice for you. Okay, so now we're going to use or discuss cross rate tables, and you see these are often represented newspapers, business travel magazines, now mostly on the web, on foreign exchange sites. I'm going to use one found on Bloomberg. Nothing special about Bloomberg other than they have a cross table. Okay, there's a lot of other foreign exchange outfits that also have these cross tables. Okay, and they'll represent the same data. Now, reading this, there's a special or a particular organization to how this is represented. And that particular organization is that down each one of these columns, and so you see USD for US dollar, EUR for the euro, JPY for the Japanese yen, GBP, Golf Bravo Papa, for the Great Britain pound, CHF, holy cow, what's that? It's a Swiss franc. CAD is our beloved Canadian dollar, AUD is the Australian dollar, and HKD is the Hong Kong dollar. Okay, so that's the currencies that Bloomberg provides in their cross table. Each one of these columns represents how much one unit of that particular currency can buy in the other currency, i.e. the currency represented across the row. Okay, how does that work? Let's go and look at our familiar Canadian US dollar. I see that one Canadian dollar, looking at the column, buys 0.7393 in American dollars. And I get that. I know that. That makes sense to me. I'm familiar with that. I also see that one Canadian dollar buys 0.6119 euros. It buys a little over 80 yen. It buys 0.5891 British pounds, or almost 59 cents in British currency. It buys a little over 0.7 of a Swiss franc, about $1.07 worth of Australian dollars, and about 5.73 Hong Kong dollars. Okay, so again, I have my familiar relationship there. Okay. Each column represents how much one unit of that column header can buy in the currency represented across the row. Conversely, the row is sort of the opposite. So if I look at a Canadian dollar and I look at this where the Canadian dollar and the US dollar intersect, I see that it costs me $1.35 Canadian to buy $1 American. So the rows represent how much in the currency listed on the row does it take to buy one unit of the currency listed at the column. So it's essentially the same thing. It's just approached at from a different angle. Okay. So if you look at this, and this will be on the exam because currency conversions are terribly important, and you get confused reading the table, and I encourage you to practice reading the table. And you can go to the website represented there and look at the up-to-date currency cross tables and do some calculations. Right? You can make an infinite number of problems. If you get mixed up when you're dealing with converting euros to Japanese yen and you don't do a lot of euro to Japanese yen conversions, you can step back, look at the Canadian dollar to US dollar conversion, see that you're reading the table appropriately. Okay. So let's do an example here. And the example I have is in July of 2019, the price of 1% milk was $2.49 US in US currency per gallon, per US gallon in Las Vegas, 0.59 British pounds per liter in England, and $4.90 in Canadian dollars for 4 liters in Edmonton. And we want to rank the cities from lowest to highest. 1 US gallon is equivalent to 3.79 liters. So this is an interesting problem, and this is, like Kik said, maybe a little bit more complicated than just a straight currency conversion, because we have 2 units that we need to harmonize. Right? Not only do we need to harmonize all this in a common currency, we need to harmonize this all in a unit of measurement as well. Right? Liters to gallons, we've got to convert this all into a common unit. Since 2 of the places have prices in some liter equivalent, converting to liters is the most appropriate thing. Okay, so our step 1 is we're going to want to convert all this to liters. Okay, so I'm going to want to convert everything to liters. Step 2 of my action plan is then to convert to a common currency. Okay, so we have the option to pick whatever currency we want. That doesn't matter. We'll do it in Canadian dollars because that's the currency that we deal with. But the question, if I ask you a question on an exam, or if there's a particular question a client or your boss asks you, that currency could switch around. Okay, so for instance, on the exam, guess what? I won't ask you to convert it to American or Canadian dollars. I'll pick one of the other ones just to kind of keep it a little bit more interesting. Okay, so let's take that Las Vegas experience, and let's convert that Las Vegas into into liters. Okay, so what we do know is, and I'm going to go with U.S. dollars in one column, liters in the other. Okay, basically following the same idea as we had when we were converting Canadian to U.S. dollars. I just kept the units common to a column. Okay, with those units common to a column, I see that it cost me $2.49 to buy 3.79 liters. Okay, so I'm using that 1 gallon is equivalent to 3.79 liters. Okay, this allows me to kind of sneak a ratio in the background and saves me some work. I want to know how many in US dollars it's going to cost me to buy 1 liter. Okay. So now I have myself set up as a nice, wonderful little ratio. I will cross multiply like I do to get rid of all these nasty fractions, and then I'm all set. So I have 3.79 x equals to 2.49 times by 1, isolate for x, and I see that it costs me in US currency, so this is all in US dollars here, about 66 cents, so 0.65699 US dollars per liter. Okay. Now, I want to go one step further, and I want to convert that amount into Canadian dollars. So now I still keep my units, Canadian dollars, US dollars. Okay. Now I'm going to do it the way I mentioned in the slide. So I want to know how much in Canadian dollars does this 699 represent? Okay. Sorry. Yeah, the liters. And so I have the exchange rate, and I pick 1 Canadian dollar, for instance, and that's 0.7393. I could easily have done the 1 US dollar and 1.3526, and that mathematically that would probably be easier. But when we in the popular press, often this 0.7393 is represented more often. So I've just kept that so that it's a link to our existing knowledge. Okay, but if I really wanted to streamline the mathematics, I would look at the 1 US dollar to $1.3526 in Canadian. Okay. Nevertheless, I'm going to get the same answer anyway. Set it up the ratio, I cross multiply, I isolate for x in the usual way. Okay, and that x is in Canadian dollars, 0.8887 Canadian dollars per liter. Okay, so there's my Las Vegas price. Now, next step, get myself all organized, all my paperwork here. Next step is let's look at the British case. So let's do this for England. Same kind of idea. Okay, it's already in the British price is already in liters, so nothing to do there. So I look at my Canadian dollar value, my British pound value, GBP, okay, and I see that the British 0.59 or 59 British cents per liter. So I want to know how much is that in Canadian. Right, 0.59 of a British pound. I look at the exchange rate and I see 1 Canadian dollar buys me 0.5891. Okay, I just used the column for Canadian dollars. Again, same kind of idea as before. I could have used a column for British pounds that had 1 British pound equals to about $1.60 Canadian. Okay, same as we did before. Cross multiply, isolate for x. That x in Canadian dollars is a little over $1. So a little bit more than the American price. Last but not certainly least, let's look at good old Edmonton. Already in Canadian dollars. We're just going to kind of find a, I'm going to set this up as a ratio, even though it's kind of goofy to do so, just so that I have something to talk about. But we see that we have, for instance, a column for dollars, a column for liters, and $4.90 buys me 4 liters. I don't want to know how much buys me 4 liters. I want to know how much buys me 1 liter. That's X. Same ratio. I get 4x equals to $4.90, and X now becomes $1, almost $1.23 Canadian per liter. So now I go through and I see, okay, what did we do for America? For Las Vegas, about 89 cents per liter in Canadian currency. Dollar, a little over $1 in Cheshunt, England, and about $1.23 in Canada. So Las Vegas is the least expensive, England is second, and Edmonton follows in third. And that's it. Okay, so there's your currency conversions. Lots of different contexts we can use these ratios. Encourage you to practice the ones for index numbers, but currency conversions are so terribly important and so terribly prevalent. And terribly meaning a good thing, meaning that it's quite prevalent. Okay, thank you very much.